Hey, today I want to talk about Celery. It's a distributed task queue written in Python. So Celery is a distributed task processing. You can run some of the processes on other sandbox or on other machines. And it's all Python based. It's open source. It's been a while. It's been actually around for a while, and it's very mature library and used by many different teams. The current version is 5.2. So if you're watching it in the future, then the version might be slightly different. But why do you need Celery? So, for example, if you're starting a new project, your code base is fresh, you have no data in database, so the data manipulation that you get from the API request can actually process quite quickly. So, for example, in this case, you see like yeah, all the requests actually come is processed within 32 milliseconds. It's all good. With time, though, your project might be growing. You have more complexity. You need to add more checks. You have more data in database. So the same process might be actually taking more time. So in this case, you can see that actually it takes 5 seconds, which is not great because for the users, you actually want them to get as instant response from the server as possible. So there was some actually studies, and basically the user have tolerance of 2 seconds. So if it takes more than 2 seconds, then actually for the companies, their sales might be slowing down or they actually getting less sales. And after 10 seconds, you just basically have users like just wondering like, why I'm wasting my time on this application. So you want to solve this problem. So this is an example actually of what would actually do to speed up the processing. So in this case, you have a fast endpoint that was taking 32 milliseconds. But all it was doing is basically scheduling all the long-running tasks in the background. So for example, if you want to connect to some other database or you want to connect some other website, which may be down or it may be actually just taking a long time to reply, you don't want to run it on the same request response cycle. You actually want to do the registration of the work that you're actually saving the data. So but you can process it in the future, or you can process it in parallel to the request. So you basically reply to the user. It's all good. We have the data, but the front end will be actually calling it and fetching the data, like and just doing the long polling to see if the data has been updated. And so this is an example of Celery. So you basically call the applications, sorry, you call the tasks with the dot delay, and you also have the Celery task itself. It can be in the same code base, it can be on a different code base. So Celery actually has a mechanism to call task from a completely different code base. But in most cases, you'll actually have just a monolith with both code for the Celery workers and Celery producers. So this is the producer. So this bit here actually sends a message to the queue, and Celery actually picks it up. And the way it will be picked up is basically the Celery will check, well, this worker can process this task. And it can also, well, in this case, it's just basically sleeping for 5 seconds, but you can imagine that he can be doing a lot more. And just a short example. So this is how you configure Celery. You only need one line. You need a message queue, message broker. I'll talk about it in a second, but that's pretty much it. It's very easy to set up and it's very easy to use. And so this is how it works. So I've mentioned that we have producers. So producers actually schedules tasks in the queue. And so for the queue, you can use many different backends. So you can use RabbitMQ, you can use Redis, you can use some other tools, and you can also use AWS SQS. So you actually don't need to maintain the infrastructure for this. The other bit, yeah, so the consumers will connect to the queue and start pulling the tasks. Like if there's a task, we can execute it. So they'll be executing these tasks, and actually so you can also store the database, store the results of these requests in the database. And so this is useful if you want to do some orchestration. So if you have one or two workers running in parallel, but they're split, and then you actually want to join them later. So you want to get the results after that. And so the producers actually can be either another code that's not part of the Celery worker, or it can be Celery worker itself. So you can actually have Celery workers scheduling tasks, and then some other task will be picked up. I'll talk more about the way you can orchestrate different tasks, but just want to touch here as well. So you also have scheduler, and scheduler is basically a cron job, and it can schedule tasks either based on interval or on the specific time. So if you want to run something like at 1 a.m. on Sunday morning to clean up database or files, we can do that. So what are some of the features of Celery? So one of the best feature that I've been using a lot is actually retry an error. So yeah, you can retry a task in case of some exception or in case of some error. So here you actually can see that the response that we get from the HTTP bin is 404, and there's an error. So we actually will raise for status, and by default, Celery can retry for 3 times, and you can see that retry back off, so that should be backing off 5 seconds at a time. And retry the jitter, it means that you can choose randomly between 1 and 5 seconds, but in this case, we just want to have 5 seconds in between. And you can also configure it. So actually, if you don't want to actually to retry for some exceptions, you can actually go. So if you want to retry for some exceptions, you can actually do that. So you can specify it for this one. For example, if it was a request exception, then you can only try for that. If you have your exception, then you can basically, just if your database doesn't work, then that might be not worth retrying that and just checking when your database is up. But this is useful, especially if you have API calls to other systems where you need to pay a lot. So for example, if you want to have some image processing and it takes like 15 cents to process the image, you probably don't want to retry it many times in case there's an error in your code and the external system works correctly. The other feature that I want to talk about is orchestration. So you can actually create directed acyclical graphs. So you basically can orchestrate how tasks are run. So for example, if you have, I would say, image processing, you want to do some steps initially, so like pre-process, like resize the image, create a thumbnail, and then start another task. Or you can actually start multiple tasks in parallel. So if you want to create a copy of the images in different workers, you can do that as well. So with group tasks, you can actually create tasks that run in parallel. And chain tasks, you can keep basically one task after another, and you can actually combine them together, and that's what creates the directed acyclical graph. And it actually allows you to create very nice orchestration of the different workflows that you want to run. And plus, you can also combine it with retry on error. If one part of the graph actually fails, you can retry and then continue. So it's a very, very nice feature. I've touched on beats. So Celery beat is the cron job, and you can run periodic tasks. You can be either once like in every 10 seconds, or it can be on a specific time frame, or it can be like every 15 minutes. You can specify that and you can run it. But you need to be careful. So there's only one beat service actually running. So if you have multiple beat services, then multiple tasks will be run as well. So that's not ideal unless you want to process 2 tasks at the same time. So everything Beat is doing is basically scheduling task to the queue, and you can keep the configuration either in a configuration file, or you can keep it in the database as well. Queues. So out of the box, Celery has just one queue, so all the tasks were put in the queue, and all the workers can pick them up. But you can create multiple queues. So for example, like sub queues, and you can route different tasks to different workers. So for example, if you have one worker with a specific GPUs, or like just GPUs because they're actually quite expensive, you can specify the queue that's for the task that's processed on GPUs, only those workers will pick them up. And the same, for example, if you have some workers that have access to some files, for example, I don't know, like medical data or PID data, you can actually do that as well. So only specific workers with like more restricted access can pick these files up. And you can also implement priority queues. So priority queues are not implemented in all the backends that Celery supports. So I think RabbitMQ and Redis do support them, but I'm not sure about others. And priority queue is basically if you have 10,000 tasks in a queue and you want to run one as a priority, you can also implement that. But you can specify it in the Celery configuration. So what are some of the best practices? So in the current version, all the parameters that you send to the Celery workers, they are JSON serializable at the start of at the producer level. And but previously with I think version 3, you actually were sending pickle data, and the pickle data was picked up by the workers. So in that case, there were maybe some issues with with processing this data. So if you wanted to send, for example, a class instance versus actually just using the arguments like ID of the class instance that you fetch from the database later. The other bit, if you want to future-proof your tasks, you can use keywords instead of simple keywords. So with keyword arguments and caching all the extra keyword arguments with starter KVRs, and this allows you basically to add new keyword arguments in the future, and all the workers can pick them up, because otherwise, so Celery actually checks if the arguments are not matched, and it just basically throws an error. Another best practice is actually using independent tasks. So you can execute the same, so you will be able to execute the same task multiple times. And it's actually advisable, especially like if you have retry, but you want those tasks to affect the state in the database or in some other place just once. So you basically run the task, and no matter how many tasks you run, like the same task you run, you just want to have the end state of the database to be the same. So it's something to keep in mind when you architecting the tasks. Another bit is actually using backup when retrying. So you can add a random. You could see that with using jitter or with exponential increasing backup or both when retrying tasks. So this is very useful if you want to remove the extra pressure on other systems. So for example, if the other system actually can't cope with the demand that we are putting into it, you don't want all the workers to actually restart the same second or like every single second. You actually want to have like I don't know, like 10 seconds with one random check when you want to call some other system, so it actually has more time to recover. When testing Celery, it so when you run the code and you have Celery backend running, when you test it without task eager, always eager, basically yeah, you have task running in the Celery, but you won't be able to catch those errors. If you want to catch those errors inside the task, inside where it's actually being called from, you can use task always eager, and that will execute it on the same thread, so it's not going to actually use the backend and the workers. But the only problem that actually this executes in a sequential manner, so this will execute as also your task will be in the middle of your code, which is not might be not how it actually runs when you have the application deployed. So when you have the application deployed, you will run some code, but the state at the end of the execution. So for example, when you return the response to the user, will be not the same as the you get when you run the task and the worker. So it's something to keep in mind when writing it, but task always eager actually makes it easier to test the Celery tasks and just integration between Celery and your application. For admin side on Celery, so depending on the backend that you use, you can also use some dashboards from those tools. But Celery has another library or application called Celery Flower. So it's a UI for your Celery application. So it actually picks up all the events that's happening there, and it also can pick up show you the tasks, the queues, how many retries there were, what was the flow rate, and also show you some of the results that you get from the tasks. So Celery in 2023, do you actually need to use it? Well, it depends. If you want to keep all the codes in one code base and execute in the same way every single time, and you don't want to depend on some cloud provider, you can use Celery. That's all fine. It's very actually quick to set up. But the only problem that actually the Celery was designed initially when there were no cloud. Well, there were cloud providers, but it was very early in the day. So it's mainly focused on the actual like, physical servers, and so you can use something like SQS and AWS Lambda if you want, and if that's your use case, and it's like you don't need to actually to use Celery. So like again, it depends like what your use case, and but Celery does provide you a lot of feature and benefits. But yeah, it's a good trade-off to have in mind. Like if you want to start with SQS and AWS Lambdas, it's all fine. And if you want to move further and actually expand and move the code closer to the more main, I guess, monolith, then you can use Celery. Yeah, thank you for your time. And yeah, if you have any questions, just let me know.